Okay, so welcome to the second session, and that is second week for the course of that is statistic for biomedical engineers. And I am MD Asjid Raza, PMRF scholar in the Department of Mechanical Engineering, Energy Trichinopalli. And in the first week, what we have seen that we have seen introduction to statistic, and when it's going to application to the biomedical or medical, so we told them like it's a biostatistic, and what is the application of biostatistic that we have seen. We have seen what are the types of statistic, that we have a descriptive statistic, and then we have a inferential statistic was there. Then we have seen some examples we have seen the COVID examples, maybe that drug manufacturing and all we have seen. Then after we have seen what types of data is there, we have seen some basic introduction how come the statistic is going to come into the play. So now today we'll see once we start collecting data, so we have to present it and all. Then what is that role of the that is a probability. Then we'll see some starting point of the descriptive statistic. Okay, so then after the third week, that our full-fledged probability theory, that probability theory will start, and then follow on. So first week we have seen that what are the statistic, and then their application. So what are the flow of that statistic was there? So first step, when we talk about the statistic, when we just 1 minute. First we'll talk about the statistic. So in the first step, we have that what we have the data collection. First step, we have the data collection. Once will data collection have been done, just 1 minute. Once the data collection completed, once the data collection completed, so what is the next step? Sorry for that. Some technical glitch actually is coming. Okay, so just 1 minute actually. Some issue is there with. Okay. First step was there to once the data collection completed. Sorry, data collection completed. So what we have to do? That first we have to data going to present it. Okay. After that, what we have to do? We have to give the description of that data. Okay. That description of the data will be like whether it's a quantitative data or the qualitative data. Based upon the description, we are going to say something about the inference. Okay, so this is the all full flow of what you can say a statistic was there. So if you see like in that what you can say the data, so when we'll see the data, we'll say the whether it's a qualitative or the quantitative. Qualitative is something that is a physical form. Let's say the pain or something is there. If it is going to same pain, it's going to measure on some sort of scale. So we'll say quantitative. So this thing we have seen and all. So now once the data is collected, we know the things like whether qualitative or the quantitative and all. So for our purpose, actually, the mainly the data will be the quantitative will be more useful because based upon that we are going to say their description. Based upon that only we are going to say some sort of what you can say their inference and that we were having some sort of one sample space, then we were having population. Sample space is a something that we are going to take something from the population and the population is a like what you can say collection of all sample space. Okay, so these are the all things. Okay, so once that completed, so now we have to data, we have to organize it, data organization. So that can be done in terms of the frequency distribution. Frequency distribution. Anyone have the idea? Like, can anyone tell? Anyone is there? Okay. So frequency distribution is something that we are going to like we'll be having some sort of class will be there. Some so for that particular class, what is the distribution? Let's say for a single class, we have a age group of what we can say 10 to 15, 15 to 20, or 20 to 25. So for the this class 10 to 15 class, what is the like the number we have? Let's say in the in a class for the age of 10 to 15 we have a 10 that is a 10 numbers. For 15 to 20 we have the 7 numbers and all. So that can be done to the frequency distribution. That one can be shown from the histogram. Okay. Then we have the some sort of graphical representation. The same frequency we can show into the graph form also. Then after the that is summary stats. Summary stats is something that we are going to tell about sample or population in a single number. Okay, so this is the all about the data presentation. So now we'll start. So first step in a data presentation, we have a ordered array. Ordered array means a number. Let's say we have a sample space is there. We have a We have a that ordered array is something that we have a sample space is there, or maybe the population is there. So first step we have to organize. Either it's going to start from the that will be going to from the lower value to the highest value, or maybe from the largest value to the lowest value. Okay. So that is the first step we have to do, either for the population, either for the sample. So for that particular case, what we have to for to let's say in a data set in a data set in a data set what we have in a data set what we have let's say we have a 10 kg 15 kg 20 kg, or maybe for a people have the weight around somewhere, what we can say from 50 to 60 kg. So for 50 to 55 we'll see 50 kgs 46 kg 51 kg 53 kg and all we'll see. Then after this, just 1 minute, I'll just try to figure out with this and then I'll come back. Okay, so what we have, so let's say for a sample space 46 kg, 56 kg, 57 kg, 59 kg, 58 kg, 60 kg, 64 kg, 65 kg. So first step is to we have to draw the what you can say in order array. So let's say it's going to start from the that is the lowest value. So we have the 46 is the lowest. Then so this is the one it's going to represent. From that itself, we can say the what is the mode, what is the median. We can say okay. So if we talk about the frequency that distribution, they're going to take a that we can do through bar graph, or maybe that that is a line graph also, or the frequency that is polygon, or we can do through the histogram also. Histogram, then stem and leaf plot is there. Okay, so so that is going to reveal the patterns and trends within the data. Okay, so first we'll see histogram. Anyone have the idea what is the histogram? Histogram is it just to we are going to represent the value of the class or interval. So we may like display the frequency distribution or the relative frequency distribution graphically in the form of the histogram. Let's say we have a like let's say I told in a class we have the boys and then we have the girls. So for the boys we have a, let's say 60. Let's say we have the 55. So for that we can plot like a this is the boys or then the girls, but it should be like side by side, side by side. So that will be the girls. So it's something like we have to show, or either let's say in a class we have like age group 10 to 15 or 15 to 20, 20 to 25. For this group, how many numbers we have? Let's say 20. For this group, let's say we have the 30. Let's say for this we have a 25. So that can be represented like it's like we'll take x-axis and then y-axis. X-axis is going to tell the class or interval. So y-axis will be the numbers or the variable. First one is that is the one age group. Second one will be the second age group. Then third one will be like this. So let's say first one is that we have like this. It came like this. Second one can go like this, and then third one can go like this. So what through the histogram, sometimes we are going to see the distribution of the data also. Like if let's say like this, so it can go like this also. So whether it's going to normally distributed or not. Okay. So This similar way that the histogram, the value of the variable under the consideration and the represented by the horizontal axis and frequency distribution. So this is the, if that's the listed, we have the one example is there. That is true class limit. True class limit is there. One. Then we have the frequency number of the 11. For this class, we have the 46. So for their histogram, it will going to look like this. First one, we have the 11 number, 46 number, then 70 number, 45 number, and all. So the purpose of histogram is to show the distribution of the any class. Okay, so this is the all about the what you can say histogram. So second one is the frequency polygon. Frequency polygon is nothing. It's like we are going to draw a line graph on the what we can say some sort of histogram, or maybe what we can say we'll take their what we can say there that is the midpoint we have. Let's say this is the histogram is that. So we have to draw the line graph connecting the class midpoints. Okay. So for this we were having 11, and then after it came this one. So it's going to show the again distribution. So based upon after seeing without doing analysis like whether the data is normally distributed or not, will be able to say visually, okay, data is normally distributed or not. So we can say through this that is this way also. So this is the all about the frequency polygon. Frequency polygon is something that instead of drawing the bar graph, we have to draw the line graph. So that can be drawn on the what is where connecting that the line connecting the class midpoints. Okay. Actually, before the things that in the second week we'll see like data presentation we have to see when data descriptive data we'll see, and then some introduction to that probability we'll see. So this is the all, and then we'll solve some last questions for some sort of example that question that is going to help you for your that what you can say quiz for the second week of the assignments. Okay. Then we have a OGIF. OGIF is like cumulative frequency graph. Anyone have the idea what do you mean by cumulative frequency? Cumulative frequency. Anyone knows that? Okay, cumulative frequency I will explain. It's something that summation of the previous frequency will say. Let's say for that age group, and we have the numbers. Let's say this is the 0 to 5, 5 to 10, 10 to 15, 15 to 20. Okay. So in that case, what we'll do? Okay. So we were saying the frequency that a cumulative frequency. Okay. So in that, let's say that's for any group of sample space or the population, we have that the 0 to 5 is the somewhere 10 numbers. For this, we have a 20. And for this, we have a some sort of like 35. And for this, we have a somewhere again 25. So their cumulative frequency will become, let's say for this it will be 10. So cumulative for the second one it will become 10 to 12 to 30. For this it will become 30 plus 35, it's become 65. 65 plus 25 it become 90. So this is the cumulative frequency. So to just to the show the form the graphs, so that graph we are saying O give graphs. So that's going to be like that going to help to visualize how the frequency accumulate over the class intervals. Okay, so it's going to be a will plot less than okay cumulative frequency versus the upper class boundaries. Let's say we have the boundary that is the first one is the 0 to 5. So this is 0 to 5, 5 to 10, and then 10 to 15, then 15 to 20. Then this plot will be going to show the cumulative frequency. So first one is the 10, then the 30, then 65, then 90. So it's something it will going to like this. So it's again a showing to like that how it's going to vary frequency accumulate once the time progresses, or maybe that our class got progresses. So this is the another method of to show the frequency distributions around. Okay. Before the pie chart will show, like we have one more that graph is the stem. What we can say, a stem and leaf plot. It's again a similar to histogram only. How come? Last we have seen the some example age group, and then we have seen the numbers. For the 0 5, we were having some 10 numbers. 5 to 10, we were having some 15 number. 10 to 15, we were having somewhere 35 number. And 15 to 20, we were having around somewhere again 25 number. So stem and plot, we can see stem is something, we have the tree. We have the tree. In a stem, there will be plenty that the number of leaf, that is the number of leaf will be more. Let's say we have the one stem, that one leaf, second leaf, then third leaf and all. Similar way here, for a this is the class will say term as a what we can say stem, and the leaf will say in terms of number, like they what is the frequencies and all we can say. So that plot will say is that is the stem and leaf plot. So we'll come to the pie chart. Pie chart is to show the proportional distribution of the frequency across the class interval. That is similar example we have. We have to draw a circle. We have to take the what is the number actually total number 25, 35, 15, 10, whatever the 19 number will come. Then we have to say in the one class we have the this much number is there. Then second class, third class, then fourth class. So it's something we have to show the proportional distribution. It's something to show the distribution class and all we have to show. Okay. Then we have a static versus dynamic data. Static data, anyone have the idea, like by the name itself, static and dynamic data. So once we have seen like data and all, so we have to see whether the data is static or dynamic. That the static data will say that the data captured at a single point in a time, single point in a time, can that is not going to change the with the time. If we talk about the example test score of the batch, it's not change with the time. MRI image at a specific time or the survey results. Or if we talk in the biomedical, we'll take the blood sugar. That is sugar level is also will say this is also a static data. If we take at one point of time, let's say 10 a.m., that some value came. Again, we'll take after like somewhere 11 o'clock. So it's again one value will come. So similar way, static data, it's going to that is not going to change with the time. Okay, so it's a static data. If we talk about the dynamic data, it's going to data that evolve over the time. So means when the time progresses, so this value will also going to be a change. Okay, so means collected as a time dependent sequence. Let's say like it's in the dynamic data, it's going to be always time will be the one factor. Always. This is going to use in the some sort of prediction or the monitoring and all. Let's say someone got the cardiac arrest, or they got admitted to the somewhere some sort of, so they will going to monitor for they'll say no, we are going to keep on observation. So they will keep the ECG and all, they will take it, or maybe they're going to connect some devices, so they're going to monitor that is the blood pressure rate, or maybe that their heart rate and all. What will happen at the time progress, we'll see some sort of their AC data like this, or maybe their what we can say BP and all, we'll see all in the real time. Okay. If we talk about the EEG also, they will also going to take the data, will do some sort of any that activity, we are going to collect their EEG data, or maybe let's say we have the EMG. We'll do some sort of exercises or any activity that we are going to conduct. The volt will be the y-axis and time will be the x-axis. So similar way, so whenever we have the any of the biomedical data or any data that is going to evolve over the time, so that data will say dynamic data. And if that data particular is independent of the time, so that data we are going to say static data. Okay. So if we see some examples, so we have a heart rate over the time. Let's say someone is going to wearable watch is there we have. So that is also a they're going to continuously monitor when let's say they're going to do the some treadmill activity. So for that particular treadmill activity, what will they will going to collect from the starting to the end, and whenever that activity or they're going to peak that is a threshold, or maybe they're getting fatigue, so their heart rate it will get shoot up, so that will able to see through the watch, so that we can stop it, or we'll try to monitor, or we'll try to we will make sure that not shoot up and all, or the EMG signal during the motions also, or gate pattern that the recording we can see. So this is all the dynamic data. So if we say the static that data that histogram, that is a histogram for this sample, this is their frequency. For this sample, this is the frequency. So it's going to be like it's not going to change with the time. If we talk about the dynamic data, so that is the heart rate. This is the time. This is the time. So it's going to evolve. Let's say it's starting with that like this. It got shoot up here, then came down, again came down very low value, then again shoot down. So it's going to change time to time. So that data will say dynamic data. So then again we have the time series bar graph. So time series bar graph. So as we have told, so whenever there is a time is involved, so that particular it's going to be like that type of data. If you're going to plot, so that data we have to plot in the time series bar graph. So x and y axis it can be of anything. This value, this value can be of anything. Let's say this can be a heart rate, or maybe the EMG, or maybe that temperature, body temperature, and all that can be there. So through that we can get the trend or their seasonality or changes over the time. So these are the data that is going to use in biomedical finance or weather forecasting and all. So if we draw their average or somewhere, it going to like this. Okay, it's going to like this we can see. Or sometimes we have to draw their analysis and all. We have to get that whether the data is whether the data is normal or not, or whether the when the time changes. So for one particular person we have some value, second person we have second third value, so we have to compare whether the first and second have some differences are there or not, something like based upon their physical activities and all we have to see. So this is all about, so we can plot in a time series bar graph and all. So for this all plot, like we can draw in the MATLAB also. Let's say we have the like I will show till. Okay, first we'll discuss the box plot. Till box plot, then we'll go to the like the code. I will show you like how to draw the histogram, or maybe how to draw the pie chart, or maybe the box plot on all. So now that is the next plot. We have the that is that is the box plot. This box plot it's very useful in actually in the statistic. Okay, in statistic, whenever we have to anything, we have to show that their distributions or something. So we have to use in the statistic. Like it's going to be like they will give the multi output. They will give the what the minimum value, what is that quartile, what is the median, third quartile, and all. So the box plot is a graphical summary of data set using the 5 number summary. First one is that minimum value. Minimum value, what is that? No, just see for the range, maximum minus minimum. But for box plot, this is not the that this minimum. For this box plot, we don't have that max value. So actually, this is going to be an outlier. So any point in an outlier, what is the value? That is the value. So for that, we have the formula. We can calculate it actually. Okay. So If we talk about the range, so first we have to calculate the range. Then after quartile. Quartile means, let's say quartile itself, let's say one value is there. Quartile means we have to divide the data into the four. Okay, like some equal four times. One, two, three, four. One, two, three, four. So first quartile will say 25th percentile of the data. Second one will be going to median. Median is going to be like they will say where median is the value they are going to divide the data set into the two parts. Okay, that's going to be itself, it's going to add the mid itself. Then we have the Q3. Q3 is the 75th percentile, means third, fourth of the pattern. Then the maximum value. So if you're going to calculate the range, so range will be the max to minimum. If you're going to calculate the interquartile range, so this is the value from Q1. Let's say this is our box, and this is that is the max outlier. This is the min outlier. So this will say IQR. IQR means interquartile range. So interquartile range, it's going to be Q3 minus Q1. So that the IQR actually it's going to represent the range of the middle 50% of the data. Okay. So actually, this thing we'll see once we'll go into the statistic, and maybe that is maybe the probability also we'll see like how the things coming out and all. Okay, it's going to help to measure variability where it's going to affect it, like where the data whenever the outliers, it's not going to affect the median value and all. Okay, so to calculate the minimum value, so we have to calculate the Q1. What is the Q1 value will be there something when Q1 or minimum value. It's going to Q1 minus 1.5 of interquartile range. For this maximum value, we have to find out. So Q3, it's going to be like from Q3, from here to like Q3 plus 1.5 times of the interquartile range and all. Okay. So this is the all about the box plot. To draw the box plot, we have the let's say data example is the 5, 7, 8, 9, 10, 12, 14, 16, 18, 15. So for to plot the box plot, so we have to draw the box plot and data. Title will keep the manual box plot data. Then Y level that's the value. That's the grid on. Let's go and we'll see that what we can say. That is the MATLAB code for this to draw till here. We have this value. I have taken some values. Let's say for a class limit. Hello. Okay. For a class limit, what is that? We have some values are there. Based upon the value, now we have the frequencies also we know. So to draw the histogram, we should know the frequencies and upper limit and all. Then to draw the frequency midpoint, then frequency rows, then for the drawing the bar histogram. So we can see for frequency polygon, we should know that because we have to start from the zero. So we have to go to the extended midpoint. It's going to start from the zero. Then the midpoint row at the end that we are going to fix it at the after 10. To draw the overlap plot, that we are going to draw that frequency polygon line and then the histogram. Then we have the OG plot. So we have to calculate the cumulative frequency. Cumulative frequency I have explained also. And for the pie chart also, frequency rows, class label that directly we can give it. For the time series data, we have the time from the 1 to 30 and the value is somewhere values are lies that like this. Then plot time series, that directly plot time value. This is going to be like that is the marker. That is going to explain about the line width. And what is the line width? That is 2. And then color we have that we can keep the RGB. Then we have the slide level. Then static data, dynamic data, we can also plot here. Then if you're going to run it, so we'll give that the all curve will look like this. So this is the that's the box plot. That is the this is the red line. It shows as a median. This is going to be outlier. This is going to be a like that is the max outlier. This is the that is the mean outlier. Okay. If we see this is the static data, then dynamic data. For the time series graph, then we have the pie chart distributions, then we have a okay that the plot, then the histogram plots are there. Now we'll come back to the plot itself. Okay, so now we have another type of plots are there that is called a spider plot. A spider plot, it's like they're going to show the multivariate data in the form of polygon on the that is the radial axis. Each axis is going to represent a different variable. So it's going to be actual for the comparison. Let's say how come? Let's say any of the heart patient is there. We are going to, let's say first one is the that is a mild, mid level, and then severity. So for that, let's say that is some number is there, some values are there. For this also some values are there. This also we have the values are there. So we are going to compare that which one have the more intensity or which one have the more impact. What will happen for the severe cases? What will happen for the another cases and all? Okay. So actually, it's going to use for the comparative analysis across the categories. That is going to use for the biomechanics. If you're going to compare the multiple, that is the muscle activation or sports sounds, that is the athletic performance, that is the matrices, and maybe the medical diagnostic also. It's going to show the symptom profile comparison also. Okay, so a spider plot is nothing. It's something that going to show some sort of comparison all also. For this also we have the for this also for this also we have. So a spider plot, if we draw, so how it will look like. Let's say I will explain the data also. The data for that rest condition we have that is the muscle activation. For the moderate we have this type of data. For the fatigue cases we have this data, and the label is the rectus femoris specus medullaris. That is the muscle's name. Then we can plot the polar plot that is NN, and then we have to convert it. So we'll get the curve like this. Like this we can get it. Okay. Now we'll come back to the again. So actually, whenever we have to compare between the muscles or between the muscles also, between that also we have to compare with the different activity or that maybe the pain level and all. So we can do through the spider plot and all. So now after the plotting data, so first step we have completed. Now the data collection completed. Now like pre-analysis, that also we have done. That is using the data presentation. We have drawn some sort of some histogram, some plots we have seen. So now we have to summarize. Summarize the data is like is description of the particular data. Now we have seen the distribution of the curve, distribution of the data we have seen already. So now from this description, like that distribution, what is the description? What is the single value we have to give it? The data summary. So for the that the data summary, first one is the it's going to measure of the central tendency. In that, it's going to be like mean, mode, and median. This will going to give the idea what is the average value of that particular data set or sample or the population. Actually, whenever we are going to talk about the statistic in that, especially in the field of biomedical or that is the medicines, we have to take some sort of sample from big population, because whenever we have some drugs and all, some vaccine will come, so we can't administer to the whole population. Okay, so what it will take, that will take some samples. So that samples numbers also we have discussed that in the last class, like how to calculate the number of samples. We have a for samples calculation, we have the G power software is also there. So based upon that, our power and some other factor and all, we can get the number of sample, what will be the optimum number of sample to validate that particular, and let's say that is the vaccine efficiency or maybe the drug efficiency and all we can validate actually. Okay. Second one is the measure of the variability. It means how the data are spread. It will say the variance or the error, skewness, and all. So we can say like how the data are variable. So now we'll see one by one what is the mode, what is the mean, then what is the mode, what is the median, then we'll see the what is the variability and all we'll see. So if we talk about the measure of central tendency, it's going to help us to understand the center or typical value in a data set. It's like an average value. What is the overall average value? Overall average value. So for that we have a mean, that is the median, and then that is the mode. So that the mean we have a arithmetic average, or the median, it's going to be like something they're going to divide into the divide data set into two half or maybe two parts. Okay. Then the mode frequent value is like categorical and discrete data value. Actually, whenever we have the data set, so let's say 10, 12, 12, 11, 11, again 12, then 12. So if you talk about the mode, so 1, 2, 3. So that's going to be like 12. So that's going to be like, that's going to be a mode. So if you talk about the mean, so we have the whatever the number of data set is there, and that summation of all data sets x1 plus x2, x3 till xn by number of data set. So it that will say mode actually. No, that's going to mean. Sorry. Then we have the median value. Median value after sorting out, it's going to like say the so skewed data and all. Then the mode value, it's going to be a most frequent value. So this is the all about the more that is the central tendency value. Central tendency is again this thing we have seen. This is also descriptive only. Based upon this data, we can't infer or we can't give any conclusion about the sample or the population. Okay. So now, if we talk about the that is the so that is a measure of central tendency gives us the center, but we also need to know how the spread of the data is there. Let's say central tendency, it will give what is the average value. But the thing is that whenever we have to know about the particular data set, and also we should know that how the data is going to spread out, whether whether the particular data is going to be like that the lower side or upper side. If the data is going to be too much on the lower side, so it's going to be skewed to that lower side and all. So whenever so that's why whenever we have to know that something, because this value can be affected with the number. Let's say for the lower side, we have the 10, 10, 10, 10, 10, and such suddenly we kept 30, 30, 30. So overall somewhere will come 25. But the thing is that most of the data was somewhere here only. So we have to show like what is the spread of the data, how the data was spread out and all. For that, this person actually it's a variability or a spread of the data around a central value. So for around the average, let's say this is data value. Around the average, how the data is going to be like skewed like this and like this, or maybe like this, or maybe like this. So this is the all we have to explain. Accordingly, we can say if we are going to conclude based upon this, what we can central tendency itself, it's not going to be fair always. Okay. So that's why we should know the what will be the error, what is the range and all. So important for understanding the consistency of the data, identifying the outliers also, and interpreting the risk also. So that's why it is very important. So if from the static itself, I'm saying when we talk about the statistics, so we have to start collecting that data. So again, the data collection is also we have to some different forms are there. Maybe the primary data or the secondary data and all will be there. Okay. Then once we'll got to know that what okay whether the data is quantitative, qualitative, and all, then we have to know okay data we have to see out whether the data is okay or not. So we have to do the data presentation. Once the data is going to present it out, we have okay the data distributions also we have seen. So now we have to see the data summarize also. So that can be done through. So that can be done through the central tendency or that is the dispersion. But central tendency can be influenced. If some too much data at the lower side and some data is at the higher side, but their average will be somewhere around that the middle, so that can be influenced. So to counter that issue, we have that we should know the what is the dispersion, what is the variability of the data or spread of the data. So that is going to help for the consistency, identifying the outliers, interpreting. So some of the values are there. First one is the range. The range will be the already we all know that what is the max value minus of minimum value. Then we know the variance. Variance means how much difference from the uh, average value actually. Then standard deviations are there. Then degree of freedom. Then let's say we have the n number of data minus one. Why that the minus one? Because we have already calculated the mean value. So we have to calculate the. So that will say n minus one. Always degree of freedom will be there. Degree of freedom will be like something that number of variable. It's going to like uh, their variability we can say. Then coefficient of variations, it's something like if the coefficient of variance is less, it means data is not spread too much, it's going to close. So whenever the data going to that we are going to collect it, so their cov it should be less than 5% only. Okay. So that's the will say data is consistent. Then we have the percentile and then quartiles. Percentile we have also seen like q1, Q2, Q3, Q4. But we know the first quartile, third quartile, from that we'll get the interquartile range. Then Q2 is the median. Q4 it's going to be somewhere not like it's going to be outlier maybe. Then we have the kurtosis also, skewness also we'll see. Now we'll see one by one. For the range is something like we should not like okay whenever we'll say okay what is the max and minimum value. So, but sensitive to the outlier. If that some values are like extreme, either extreme low or extreme high, in that case, it's going to be like very sensitive. It will give not like some proper values and all. Let's say we have the 65, 68, 70, 72, 74, 150. So in that we have a maximum of this is the maximum value. Then the minimum value we have at this one. So that the range will be having 150 minus 65, it's going to 85. So this is the so we can see okay what is the range of the data. We should be knowing that. Then after the variance, measure the average squared deviation from the mean. Again the question will come why should we take the average squared and all. That we'll see in the once we'll start with the statistic or maybe the probability. First reason will be always we don't want to be in the negative. So then the another one will say okay that we can take the mode, but it's better to be have in the safer side and all. We can take the squares and all. So that we'll see in details in the coming slides, like coming the lecture. So that's going to y squared to avoid the that is going to be negative value or emphasize the large deviation. Okay, whenever we'll be having some very low divisions, so if we take them, it's going to be squared. It's going to be like a good, like we can see that divisions also. So it's going to be a, this is going to be a, we have the values, or this is the average value. Xi minus x bar square by n minus 1, y n minus 1, and y not n. That we'll see later part. Actually, n minus 1, because this value, why? Because we have already calculated like the mean, so that's a visual. So this is the all about the population. If you go to sample space, so it's going to be n. Okay. So then we have a degree of freedom. Degree of freedom when estimated population variation from the sample. It means it's going to degree of freedom is like something like the variable they have. Let's say any of motion. Ball is there. Ball. They are going to move in the x, y, z, or r, theta, phi. So they have the sixth degree of freedom. X axis, y axis, z axis, or they're going to rotate in the r or theta or phi. So it's doing six way. So similar way, for a data, we have the sample from the sample. If you're going to calculate n minus 1, so means it's going to be like they will give the degree of freedom. Then we have the standard deviation. The standard deviation is the square root of the variance. It's actually going to represent the error actually. Okay, then it's going to commonly used in the biomedical signal where heart rate variability, EMG amplitude, and all. So we have to tell whenever we're going to calculate, okay, average muscle activation is there. Average muscle activation. So we have to tell, let's say 50 plus minus what is the there deviations is there. So we have to tell in terms of percentage, 50% of the muscle activation, but what is the variability is also we have to show. So means how the data was spread out. If that value is going to be high, so means variability is more, spread of the data is more. It means the data might not be the consistent with the participants, same participants, or maybe data is not truly like properly collected data and all. Then we have the coefficient of variation. It's going to tell about the what is the relative measure of the variability here also. Let's say I'm going to conduct a experiment. I'm asking to apply a person to 100 Newton of force. Okay, but participants, because the thing is that that is not going to be a like anyone control. They will apply the force. It's going to be one not that is the Newton. Someone might apply 99 Newton only. So let's say we have the 100 participants. So we'll be saying, okay, we have collected the data. Sometime it went 104 also. Sometime it went to 94 also or 1110 also. But the overall coefficient of variation is was less than 5% was there. So means we have assured that there is not of much variability was there while collecting the data was there. So that is the that this variable is going to tell about the what is the relative measure of the variability. It means the compare variability across the different scale. Let's say mean 10, standard deviation is 10, so it means coefficient of variability is 10, or mean 10, so it's going to be high variability and all. So whenever we have the some biomedical data, is it always advisable to keep the coefficient of variability less than 5%? It should not go more than that. Until unless we have very high sophisticated data, we can't control its change with very, that is the what I can say, low impact or something and all. Okay. Then we have the percentile. Percentile, we already know that what's going on. The value below which how much data percent for. Let's say I have 100 percentile, like 20% of the people are graduate. Okay, or we'll say like 30% of the population of sample we have some sort of fever or flu was having, have flu. Okay, so it's something they're going to tell about the data, like that is percentage of that. That's a percentile. And then we have the quartile. Quartile means dividing data into the four equal part that we have seen in the box plot. Okay. First one is the Q1, 25th percentile, Q2, that will be the going to median, Q3, 70, and then we have the interquartile range also. It means middle 50% of the data, it means Q3 minus Q1. It's not a range. Don't confuse with the what we can say max minus min. Again, we have the some formula to calculate the Q1, then Q3. We have the some formula is there to calculate actually. It means it's going to robust to the outlier. Then kurtosis. Kurtosis is the major tailedness of the distribution. I told one time, like if the data is normal, the distribution look like this. If data is that is a lepto, so it's going to like this, like very peak and all like so. Or if the flat like this, so it's going to be like a plateauquartic and all. So they're showing the how the data was variable. It means if the data is normally distributed, it means the data is like fairly distributed. Otherwise, it gets some are having outliers and or all values are close, always low, low, low. It means that is not like it's a flat. So now we have discussed about the data summaries. That is data summary. So we have seen out. So we have checked about the how what is the overall average value or what is standard tendency, like how the data is what is the overall value, and then we have discussed the how the data are spread or the variability of the data how we have seen. So after that, once we know this thing, so now we have to slowly jump into the statistic. So whenever we go to the statistics, so we should know that statistic is without the probability that a statistic is nothing. So we have to start with the probability also. So now we'll see the probabilities. So the theory of that is a probability. It's going to foundation for the statistical interference. Without probability statistic, we can't go ahead with that. So so what is that? How can we define its probability? It's a chance of the occurrence, and we all know that whenever maximum probability will be one means 100%. So chances of occurrence is something. So non-occurrence will be always one minus like chances of the occurrence and all. So, whenever we are going to talk about the sample point, is the most basic outcome of the random experiment. Again, why we are saying a random experiment and all? So, let's say we had some box was there. So, two, three, then something. So, they will take randomly and all. So, it's again a random sample space and all. Wave event, something outcome or set of outcome that is our of interest. Let's say I'm going to coin the toss. Either it's going to be head and tail. So, that head is the event. Tail is the again event. Okay. So event we have to define something that is our interest. Let's say I'm saying something. We are going to throw the dice. Throw the dice. Okay. One, two, three, four, five, six. These are the our interest. Either it can be one, either it can be two, either it can be three, either it can be four, either it can be five, either it can be six. Understood? So this phenomena we are going to tell event. Then we have the sample space, set of all outcomes. Sample space is going to be like all this value that's going to lie in the sample space. So probability is going to measure the likelihood of the an event occurring. Okay, so means chances of the occurrence we can say. So that is how we can define it actually. Actually, just that I am giving the brief when you're going to start something so I think that you might have already doing that, but still I'll give the brief and all. Then it's going to value, they're going to range from the zero, it's going to impossible. Whenever will say something will happen, so it's going to something 1% or 20% or something will be there. But certain 1% it's going to certain. Types of the probability, that is the probability, it's going to be based upon the logical reasoning. Empirical probability based upon the experimental data, and subjective probability that is a probability based upon the belief or experiences. Mostly we will discuss about the based on the experimental data only. Will not discuss That is the logical that is the reasoning and all, or the belief or experience. Will be going to mostly discuss on the empirical probability itself. Okay. So now we'll come to some sample space, all possible outcome. For a coin twice, we are going to take heads and tails. Event E, a subset of the sample space, it's going to be E head. Or axiom of the probability, it's, or maybe the, maybe we can say some rule or foundation rules. Probability. So that is for any event, their probability is going to lie from 0 to 1 itself. Either it can't be go to the it can't go to the negative, or it can't go beyond of the one also, or summation of all probabilities of any event. It's going to be always one. It can't go beyond of the one. For a mutually exclusive event, so P of A union B, it's going to be a like PA plus PB. Or again, no, this thing will see that in the detail in the coming class. Or if the event are independent, so P of A intersection B, or maybe so PA into PB, or something like this. It can go PA union B. It can go PA plus PB minus PA into PB. So this is all about that thing. We'll discuss the rule, probability, conditional probability. Then we'll be having a like a probability distributions will be there. Then we'll be having a Bayesian theorem will be there. We'll all see in that. So let's say we'll take some examples. Some person going to like coin the test, toss the coin, toss the coin, either head or either tail. Okay. So to that is the probability of head will be always like it's going to be like chances of the occurrence of the H and by total number of event. So 1 by 2. So means it's going to be always 50-50 whenever you're going to, or let's say one person have tossed the coin three times. Head, 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 tail. So similar way it can go like we have to follow the NC3, 3C1 or maybe something we have to follow it up. Then we can get the number of space and all. Okay. So now this is the all basic of the that is the basics of the probability and all we have seen. Now till now what we have seen actually we have seen. Now I'm going to summarize actually. We have seen the data presentation in the form of the histogram or the graphs and all. Then we have seen some sort of descriptive measures like how the data overall, like the data summary, we can say we can get a numbers value and all we can say. So for that particular case, what we have seen, uh, measure of central tendency we have seen. Then in that also we were having a like mode. Then we were having a mean. Then we were having the median. Then we have seen the measure of the dispersion. Dispersion, we have seen the many variables we have seen, like we have the range, we have the percentile and quartiles, we have seen the standard deviations, we have seen the variance, we have seen the interquartile range, we have seen the skewness or the curtosis we have seen. Okay. After that, we have just introduced the probability. We didn't with the what is a that is a probability and all. We didn't see their cumulative properties or maybe their independent properties and all we have that we didn't see. Okay. Then after we have seen like what is the event, what is the sample space, and what is the fundamental rules like a probability that can't go beyond of the one or below of the, like it's going to be that's not going to minus. Okay. Then we have seen the for a mutually exclusive that uh, event P A union B, it's going to be P A plus P B. It's like mutually exclusive means it's both are independent. So their probability is going to be always summation of the individual probability. So now we'll see some example based upon all these things. So first example we have a which of the following is the primary purpose of the data presentation? When we talk about the data presentation, so our aim was to visualize what distribution or to see the information, to see the information clearly. So to collect the data, it was the first step in a statistic. Whenever we are going to start anything in statistics, so that is going to first step to collect the data. The data can be of anything. Either it can be a primary, either it can be a secondary. Primary is something that we are going to take from the experiments and all, or secondary data is something that already done by someone. Maybe it can be from the federal government, or maybe the secondary person they have done and then they kept in the public domain. So that is the this is the first step. So this can't be the objective or purpose of the data presentation. Second one, or the third one to generate the hypothesis. Just 1 minute. Second one we have a to communicate the information clearly and effectively. So that is our purpose is to data presentation to visualize, to see the information, what is the distribution. So effectively we can see. So this will be the options correct. Uh, just go and see the what is the third option. To generate the hypothesis. Our purpose for the data presentation is not to generalize any comment or we are not going to do anything. We are not going to tell about the population based upon the sample space and all. So it's not going to be like it's the part of inferential statistic. Inferential statistic. So this can't be the answer. Then to perform the statistic analysis, okay, the data we have collected. So our eventually main aim is to we are going to perform the statistic analysis to give any statement or any conclusion about that data. But in the statistic, in the data presentation, the aim is not to perform the statistic analysis and all, only to visualize or provide the information effectively and clearly. So that's why for the first, that is a question. The primary purpose of the data presentation will be to communicate the information clearly. Either it can be in forms of maybe the bar graph, either in forms of the that's going to be bar graph, or maybe the histogram. Okay, histogram or any plot we can see, or maybe and the data presentation also is not like we are going to give any average value or something. Okay, so now we'll go to the next question. So, so for this question, we have the answer to communicate information clearly and effectively. Second question, what we have, what is the difference between the static and dynamic data? So that I already explained. Now we'll start with the first option. Static data, if you see a data, it's not going to evolve over the time. The data over time. For a dynamic data, it's going to change over the time. So static data change over the time. So that can't be the answer. Dynamic data does not. So it's going to be like just opposite we have. So static data is a time invariant. Dynamic data changes over the time. So it means time invariant that is the time, that just say time variant means it's going to change over the time. Time invariant. It does not change over time. So for this, the answer will be second one. That we'll see the list, the third options also. The data requires a frequent update. Okay, that is the one part that required, or maybe that not required also we can say. Static data is not going to be like for a time there is nowhere relation it's going to be a dynamic data that does not, but the dynamic data it's required. Static data is always numerical. That is not always possible. Numerical data is always categorical. It can be of anything. Static data can be categorical, or the dynamic data can be that is the categorical and all. So that statement is always like it's going to be like false in terms of static and dynamic data. So first that option we have a static data is time invariant. Dynamic data is not going to change over the time. So second option. So static data used for the baseline profile. Static data is something that we are going to use for the baseline profiling. How come? Let's say we have like HRV, heart rate variability. Somewhere, like maybe it should not go beyond of there is a certain limit. 70 will keep, or maybe the 50 will keep, or the 30 will keep. Now we are going to manage, see the data in a real time with the time. If that HRV rate is going to beyond of this limit, so will tell. So that HRV will become the baseline. That static data will become baseline for the dynamic data. For the dynamic data, that static data become the baseline for the particular. Dynamic data is used for the monitoring, train analysis, and then the real time signal processing or real time scene. Okay. So I think that will be the static data and dynamic data is clear. I think so. Then we have a third question. Third question is that which of the following features can be identified using the box plot? Which of the following features can be used identifying using the box plot? Can anyone tell if anyone is here? The box plot. If you see the box plot, we have the 5 point summary. Anyone is there? Yeah, is it in intercodal that will be there?
Yes, sir. Intercodal.
Okay. So that mean we can't see. Is it? We can see the median, we can see the interquartile range. So this is our Q1, this is our Q3, this is our outlier 1, max outlier, this is the mean outlier, this is the Q2. So Q2 is nothing a median. So we can see the median, and then interquartile range is nothing is a Q3 minus Q1. Okay. So we can see the interquartile range also, median also, but mean we can't see. So box plot is not going to interpret the mean. Standard deviation also is not going to mean. So this two can't be the answer. So for this we have the median and interquartile range. Now we'll come to the next question. So now we have the which measure of the central tendency is least affected by the outliers? It's again a tricky question actually. We have the central tendency. Okay. First one is the mean, then mode, then we have the median, then we have the range. So if you talk about the this can't be the things. Why? Because this is not the central tendency. It's actually a measure of dispersion. Measure of dispersion actually. So this option got ruled out. Now just tell me about the mean. Mean, they're saying the outliers. Outliers is something that is going to be like either extreme or either it's going to be like very that extreme in either case. Either it's going to very high or very low. So if the values are too much in the very high or very low, they're going to that definitely is going to affect the mean actually. Let's say too many values are it's going to be like that like going to extreme cases. So that value is going to be a like it's going to affect the mean. So it that can be the answer. Mode. Modes again it's nothing they're saying set more frequent value. Means mode is nothing but a more frequent value. So they are not bothered about what we can say. They're not going to bother about it can be bothered, but it there's no related to the outlier or something and all. So median is going to be least affected with the outlier. Why? Because once it tell like here, so then outlier and all, it not going to change. Either it here, either it here, either it here. Some outlier can go different. So we have the answer for this is a median. Okay. The mean can be affected by the outlier because an outlier is a that value. That value is calculated from how? Because it's going to be summation of the all values by the numbers of the let's say the sample. So it's going to affect or it's going to influence the mean value. That the median, what we are going to say, we're going to form the number in the ordered way. Ordered way. Then we are going to find out the somewhere middle value. So that can be a value can go anywhere. It can go somewhere here also. It can go extreme high, extreme low also. So that's not going to affect with the outlier. That middle can be the middle at the one place itself. The mode also is something. It's going to be like vary. Why? Because the outlier, if the number of outlier is more, that the number of that is the low value is more. So that mode is going to be at the lowest value. If that is that outlier extreme high value having that the most frequent value at the high value, what will happen? That mode is going to be like that value. So it's something that's going to affect it with outlier also. If that outlier is going to more and more numbers, but the median is going to be always at the center because we're not going to calculate or we're going to process the data. It's going to be something we're going to keep in the order from the lowest value to the highest value. Then we're finding out the very the middle. That middle is the median. So that's not going to be influenced with the outlier. So that's why for the standard tendency, it's going to least affected with the outlier. So for this, we have the answer of median. Then we have the fifth question. We'll see when we are going to summarize the data. Which of the following statistics are typically used? We have seen When I started the classes to the session we have started, so I started with the data presentation. In that we have seen some histogram, some graphs, some plots we have seen. Then we have seen the data summarizing. In that also we have seen central tendency. Then we have seen the measure of dispersons also. Dispersons also. Central tendency that we were having some three like mean, mode, median. Dispersion we were having some standard deviations and all. So data summarizing. So this histogram can't be the answer because it's a data presentation, not the data summarizing. It's something to communicate or to show the distribution of the data, not the like what is the average value, how the data is going to spread out and all. That is going to tell about the mean, standard deviations, and data quantity. So this all three will be the answer. I think for your Qs, we have what we can say that is a multiple choice question, and then you can put multiple options also for that. So this is actually a multiple choice answer. First question was there. So for this question, we have a mean, standard deviation, interquartile. From all this, we can summarize the data. But through that, we can just show or visualize the data and all. Okay. So histogram is actually a graphical tool, not a statistic. Again, it's a tool to visualize the data. It used for the visualizing the data that distribution, not summarizing the it going to numerically. Understood. So this, I think this can be the clear. Then we have the sixth question. We have the in the probability theory. What is the sample space? When I discuss about the probability, we have discussed about the event also. We have discussed about the sample space also. So now we are saying what is the event? What is the sample space? Event is something that is our interest. Let's say I'm going to toss the coin. I have told this uh, example already. Whenever I'm going to toss the coin, so whether it's a head or tail, that head and tail is our interest. So that point will become event. And if it tell about the sample space, so both head and tail is going to be in the sample space. Okay. So event is something that is our interest. Event is happening. Let's say we have the marriage and all will be happening. In the marriage, some event will be that some sort of haldi function is there, or maybe some sangeet function is there, something is there. So that will become event. But if we told about the full setup, like for the wedding, so that will become the space. So, so first option we'll see the set of all possible outcome of a random experiment. Okay. Then after, so again, this can be that will keep on hold. Then the event that is most likely to the occur. Again, it's random only, not can be the event. Like event is there, but that is going to that is most likely to occur. Then collection of the all event. Then to the set of outcome that have the zero probability. It's like there's all possibility in a sample space that can be of any purpose. That is a possibility. So means it's going to be like collection of all events, sample space, event that is going to most likely to the occur also. Then after the set of outcomes also that the event is most likely to occur that can be sample space. Why? Because it's become an event. Let's say, or maybe we are saying that how frequent a event that's going to happen. The collection of all event. It's also will say, but the collection of all events also we can't say. Understood? The the set of outcome that have zero probability. It's become a rare event. When something we are going to tell, there is always chance 0.5%, 0.0001% also chances will be there. There's some sort of probability will be there. Zero can't be the probability for an event. Like let's say outcome I'm saying. Whenever we are not going to do anything, so that is the probability of zero. Nothing happened. It's an ideal case. It's going to be zero probability. Okay. So that answer will be the set of all possible outcome of a random experiment. Then the next question we have a if a die is rolled, which of the following set represent possible event? Can anyone tell? Whenever a dice we are going to roll one, two, three, four, five, six. So this is become your sample space. Now they're saying which of the following represent the possible events. First one is the one, two, three. There is always chances is there that dice when we have thrown it out, either its all values are odd value. So it become a one, two, three, or one, three, five. One, three, five, or maybe the even value. Let's say two, four, six, or maybe the continuous value. So there is event possibilities of event is there. I throw the dice three times. So there is always chance. Sometimes the first dice came one, second dice came three, third dice came five. Is it? So there is chances is there. Well, even let's say I have thrown the dice, it's the even time. So it can be like no, that not the even time. I have thrown the dice, but it came two, four, six. It's all this is the even came. Or I have thrown the dice, it came one, it came two, it came three. It's again a chances of event is there. Because whenever it's going to be 1, 2, 3, 6, it can come anything. The D also 1, 2, 3, 4, 5, 6. I have thrown the dice, it came six time. Six time I have thrown. First time it came 1, 2, 3, 4, 5, 6. So it's going to be answer all will be the answer. Like it's going to all are the valid events if we are going to throw the dice in any cases or any sample space. It's just a like what you can say case. Whenever I'll say like I'm saying okay, I have thrown the dice for 10 times. In that odd number of came 1, 3, 5. Okay. That the event 2, 4, 6. It's again event is there, na? It's I'm not saying I have thrown the dice two times or three times only. I have told them like we have thrown the dice. Dice is rolled. There is a possibility will be like 1, 2, 3, either 2, 4, 6, 1, 3, 5, either 1, either 2, either 3, either 4, either 5, either 6. Is it? So there is a possibilities are there. All are valid events are there for a dice in the case of probability, for the case of event actually. Then we have a eighth question. So now in this we'll take some sort of application question. Whenever a researcher is going to investigate the daily number of website for an e-commerce platform to understand the traffic pattern and improve the market strategy. Okay, so any of let's say you are a statistician, then some company that they have hired you and they are saying, okay, you are the statistic person and all. Now you see that I have the e-commerce website and all. So they are saying what is the traffic pattern and improve the market strategy. Like from which section of the people are coming to the that is that what you can say e-commerce. Okay. So in that case, like some sort of case study is there. So now we have to which why the quantitative data particularly suitable for this analysis. So now we have to say like we all know that what is the qualitative data? It's something physical like pain or gender. Anything is there? I'm just seeing popping up something. Yeah, please. Yeah, physical. So qualitative data is something a physical data and all. Right. Okay. Then quantitative data is something a number. Maybe that number can be of anything. Okay. So because so first option will see qualitative data is something to just interpret like physically and all. Quantitative data is something will tell about the numbers. Okay. Because it's allow the researcher to describe the browsing habits and preference of the user. If we see the keyword is the habit, it's again a physical or something different, or preference, it's a something different. So this become a qualitative what we can say assessment. Second one, because it enables the research to count the total number. Whenever it's coming, the numbers, it's become a quantitative. Okay. So count the total number of visits and analyze the traffic numerical. So it's become a what you can say, a quantitative. Let's see the third option. Because it provides the data that is always qualitative, can be categorized. So we are not bothered about the quality, because they're saying why quantitative data is particularly that is suitable. We're not bothered about the qualitative. We're not seeing like, okay, what can be the qualitative, what is the habit, and what is the preference, and all. They're not okay. So they're not bother about so. When because it always continuous and never discrete. Okay, quantitative data. It's not going to be like, it can be the what we can say, that is the discrete also, and it can be the continuous also. There is no hard rule like it will be the always continuous data and all. It's always, there is no hard rule. So so this statement is also, it's not going to support the statement. First one, because it's a qualitative itself, because of the habit is a physical and something. Then because it enter the researcher to the count, so it's going to be quantitative. It's again qualitative. We are not going to deal about the qualitative, and it's going to be continuous and never discussed. So it's going to be like, it's we don't have the hard rule now. So for this answer will be, it's going to enable the research the count the total number of visit and analyze the traffic, and that is the numerically. Now we'll come to the next question. Consider the following, that is a scenario. First scenario is that we have a financial analyst. Financial analyst is going to analyzing that is the daily the return of the two different stock to understand their risk profile. Let's say we have some such scenario. Let's say you are the financial analyst. Then we are going to analyze the daily returns. Maybe if you are going to stock, it can be a profit, it can be a negative. So based upon these two, they're going to analyze the what? It's going to analyze the risk profile. So means which statistical measure should analyze, that should the analyst use the compare the variability of return between the two stocks. Okay. So here, whenever we are going to say something like, first the scenario was two, we are going to analyze the profit or maybe the negative, whatever. Then to calculate the risk profile. Whenever it came to risk profile, it's something going to be like how much percentage change came, whether it's going to be like always loss and all. So now they're saying variability. Variability, it's going to be like not the, what you can say, central tendency and then something. It's going to be like dispersion. And if we talk about the central tendency, here for the same study, I'm saying for that, okay, let's say for a in a day, what is the average profit or average loss, or what was the revenue? So it's going to be comes under. central tendency and all. But when we talk about anything like we have the risk profile or variability and all, so it will become a dispersion. That dispersion can be of maybe that standard deviation or maybe that range. It's again something like it's a dispersion. So now we'll come back to the options. First one is the mean. When we talk about, so we have the here keyword to see. Keyword to see what is that mean? Like no, that is the variability. So variability can be the central tendency. It's going to be like always. It's going to be always the dispersion, not the central tendency. So that mean we have the dispersion. No, no, sorry, central tendency. This also we have a central tendency only. Variance is actually a dispersion. Again, the mode we have a central tendency. Okay, so that answer will be C. Okay, so I think this question will be clear. So answer is the C. So now we'll see the next question. Next question we have a if the financial analyst want to visualize the distribution of the return for the both stock on same graph to compare their performance, which graph would be the appropriate? Can anyone tell? If a financial analyst want to visualize the distribution of the returns for the both stocks on the same graph to compare their performance, which graph would be the appropriate? Just see the here we have the keyword. What is the keyword? Distribution. Pie chart is will give the what will they will give? Proportion. What about the line chart? What about the bar chart? Again, you have to see which will be the more appropriate. So that will give the proportion. Again, the distribution, but it's not going to like it. But such things will be the box plot will give a better picture as compared to the other graphs and all. So it's going to be box plot itself. Okay. So now we have discussed all these things. Okay. So can I ask one question actually? Like, shall I show the code of all what we have seen? Like, I will explain the codes also. Like, just 1 minute. Can I show the code of all what we have done? Like, some anyone please reply. Okay. I will do one thing. I will just show the code. So first code is that is the data. What we can say presentation. Let's say we have the data of the class limit of 29.5, 39.5, 49.5, and all. So for a data presentation, we have to calculate the midpoint for what? For what we can, let's say, to draw the line polygon. For a that is the midpoint row also. For the frequency row, that is the row also. And then upper class limit and then cumulative frequency. Cumulative frequency to calculate the OV graph. I think this code I have explained actually. This also I have explained. I'll go with the central tendency. Let's say we have the data 68, 70, 72, 73, 74, 150. So if we want to calculate the mean, so we all know that what is that? Mean it's going to be like summation of all the numbers by number of the data. Then the median will be we're going to sort it down from the lowest to the highest value. Then There the median that is the mid value will be, it's going to be like that the median value, and the mode value, it's going to be like most frequently it came. So for this we don't have the mode value because it's not going to all are single value only. So now we can see, okay, what is the value of that mean value and all we can see. So we can plot the histogram. If you're going to run it, we can see here the that is the distribution we can see. This is the value of mode. This is the value of median. This is the value of mean. And all data are like how it is spread out and all we can see here. Okay. Now we can see that this person. This person, we all know that what is the value of the range, variance, standard deviations, coefficient of variations, and then interquartile range, and then quartiles value. Let's say for the same data value, that we are going to calculate the center value, mean value of the mean, that is the mean of the data, that is the range of the value. So that is going to range calculate means is going to maximum to minus maximum minus, it's going to it's going to mean. Then we have the that is the variance. Variance, we all know that we have the value of that, we're going to calculate the mean, then xi, that xi minus x bar to the whole square by n minus 1. Then we have the standard deviation, it's going to square root of the variance. Then we have the coefficient of variance, standard deviations by mean value into the 100. Then interquartile range is there, q3 minus q1. Then we have the curtis value. If we, for that particular data, data we can, okay. So we can, if you're going to, this is the data sets, that is the load dispersion, then the height dispersion, then the first mean, second mean, then we can calculate all the values are there. Let's say, so we can see for the range for the first data set, 65 to that is the 185, it came 85%. If you see the variance, variance is having high, very high value. And the standard deviation is also 32.89. It means it's going to be beyond of 10%. Whenever we are going to see any biomedical data and all, it should be very less value. Coefficient of variation that I told, it should be like less value itself. It's coming 39.55%. Interquartile range, then curtices. Now we can see comparison also, we can see here also. So now we'll see the probability. Now we'll see the probability. Now we are going to coin the like 1,000 coin choices. Then we'll see what will be the outcome, either head or either tail, for a number of like let's say. So we can see here for the possibility percentage of the coin, that is the probability of the head is the 0.49%. That is the probability of the tail is the 0.51%. It depends upon the how we have defined the conditions and all. Okay. Then after we have the second stock A, we are going to generate a number like that is the that is the random number, like that is a low variance. Point 0.5 is the mean, standard deviation is the 1. Then that is the similar to stock B, for that standard deviation is 5, and the mean is 0.5. So we can see that how data is going to variable, like that is the low variability. We can see there is a low variability, but this is the high stock variability is there. We can see the returns are more high in terms of like this. So this is the all about, like we till now we have seen. So till now we have seen. So till now we have seen in first week course we have completed, second week completed, the third week now we are going to see what is the discussion of mean, what is the what is the properties of mean, and then mode, and then the median. Then we'll start the introduction of the probability. Then we'll see the that is the probability distribution. Distribution will be the Poisson, maybe the normal, geometric, or maybe like a harmonic, or like other types of then we'll see the expectation. Expectation is going to derive from the mean itself. First expectation, second, third, then population variance. Then we'll start with the inferential statistics. So in the third week, we'll see basics of the inferential statistic. Then we'll see what is the central, that is the limit theorem, confidence interval. Then what is the hypothesis and all. So I think that's all for that today. So any doubt is there? Can you please ask, or can you tell about the today's session? Can anyone tell about the today's session? I think in starting due to the technical glitch and all, it become bit of lag, and I think it went well. Please, yeah, it's a Kanishka or Sal is there. Can you tell the like some feedback about the today session?
Class was okay, sir, but still little tough to understand. I felt that way. So when I go through once with your content, I may able to clear little more doubts. So in between, I also had interruption of the net.
Okay,
So I felt otherwise, okay, your explanation was good, but I felt it because of the interruption here and there. I got missed somewhere. So when I see your content, I will be able to understand. So thank you so much.
okay. Actually, that all this content and all will be available on that what you say NPTEL website also. If you want, the same video is actually uploaded on the website, like in
Email
the
also available.
I will share the what we can say the link of the videos and all, like maybe
Ah,
the channel itself.
okay, sir. If you share, that will be useful for me.
Yeah, yeah. So in this that the YouTube channel only itself, I'm going to upload all video. Actually, this thing that you can access through your NPTEL, that we have the dashboard is there. So there the PPTs are also I have given, and after this lecture, I'm going to upload the what I can say like this videos also, and the PPT I will upload on that drive also, so that you can go through that. If you have any doubt and all, that you can ask now also. I will try to explain, because the some 5 more minutes is there, so I will try to explain. Or shall we wind up that lecture?
Right, sir.
Okay, still I have some 5 minutes to left out, so I'll be here only. And I'll tell you like in the coming classes, I can say like I will try to make more of the code, and I'll try to explain on the MATLAB each and every steps. Is it okay, or either whatever I'm explaining that is fine? Let's say like for now that we have the some theory part, because we are dealing with the full of introductions and all. Once we start the that is the that is the probability or influential statistic, it's going to be full of calculation. Instead of doing calculation on the like maybe the mode, I'll be explaining the code. That's going to be more helpful. And if you are having some doubt in the that is the MATLAB also, that you can ask actually. Is that will be okay? Can you please tell?
Code will be little tough, sir, to understand if you explain with.
Yeah, no, no. What I will do, I will explain everything on the board itself, but I will for the reference actually. I can say like I will show you in the code also in the in the what is the MATLAB also. It's going to be additional part, not like I will explain each and everything on the like what how the things are done and all. Then after I will show in the that is the MATLAB also. It's going to help whenever you're doing any the research and all something. Is it?
When you explained regarding the sample space and the event,
Yeah.
so as per my knowledge, I came to know every outcome in the experiment, we call it as an sample space or event.
Yeah.
But here something different I felt.
No, actually, whenever we'll say like sample space and event, so sample space will be the combination of or combined of all event. Okay. And if we talk about the event it's going to something that is our interest. Let's say I'm going to throw the dice. The dice will be either it will come one, either it will come two, either it will come three, either it will come four, either it will come five, or this or six. So that is our interest. So that will become event. But
Yeah.
if you say the sample space, it's going to be combination of all set of possible outcome.
Okay, okay.
Is it?
Yeah, yes, sir.
I think in that slide, like some confusing words were there, but still I think that clear because the will say all possible outcome.
Outcome.
Yeah, in the random experiment or something like it's all.
So I had doubt whether sample space and event are the same.
No,
No,
event will be the independent,
independent. Okay.
and sample space it's going to be collection of all event. Event is something I'm saying that is our interest. Like let's say I'm going to toss the coin, it's going to either head or tail. Heads is the one event, tail
No.
is the one event.
Yeah.
No, but that is the combination of head and tail. That is going to be like that is going to be a sample space.
Says.
Is it?
Yes, sir. Yes, sir.
So that the similar way example I told like for the marriage also. Like we have that in the marriage, some Sangeet function is there. So that is one event. But that is not going to connect it with the maybe some sort of that like say Sangeet and all. It's a one event, but that is a part of sample space. So sample space is going to combine of all event.
Okay, okay, sir.
Any other doubt?
At present, I got this doubt only. But
Okay.
coding, when you were showing coding, I felt it was little confusing for me. So I was thinking. So the other way, when you explained, it was easy for me when you were explaining with the frequency,
Okay.
mean mode.
Okay. I will do one thing. I'll try to keep as simple as possible.
Okay,
First,
sir. Yes.
first in the PPT, I'll keep as simple as possible. If time permit, then I will explain the thing like how same thing can be done. It can be automated. It's not going to part of this, but it's going to automate it. If you are going to interest, like you are doing some computational analysis, let's say for me, for my that is the research work is it's going to sports biomechanics. That is the biomedical engineering. So I'm going to collect the number of data. I have the sample space, or that is number of sample is somewhere that is 10 lakh and that is the 1 crore. If I'll do the manually, what will happen? I'll be not able to do.
Yeah.
So that's why I'll be going to automate with the MATLAB, and then I will do the analysis and all. So it's something that just I try to like add up the things. It's nothing like we can that we can't do for this course. We can't do on that pen and paper. We can do the pen and paper itself. When I done, but that is the my first course. That was the probability and statistic at my NIT itself that we have done full pen and paper. But that the professor in the last that they told same thing you can automate by yourself using any of the like software, maybe the MATLAB or maybe the Python or and all. That's a similar way I'm just trying to uh, implement here because if we can see here, this is a 12-week course. Each week we have very small topic. So for 2 hour discussion, we can elongate that it a little bit, or I'll go like basics as much as possible.
Okay, okay, sir.
Yeah.
So nice it was.
Yeah,
Nice to
actually,
listen to
in the
you.
sorry.
Nice to listen to you to clear my doubts.
Okay, thank you. Actually, in the starting, what happened because of the I connected one pad actually to write on the board. That got bit of malfunction, so it got little bit 5 or 10 minute delay was there. Sorry for that. Now I'll try to come up with some different pads.
If you can upload your videos, please upload so that it will be useful for me.
Yeah, yeah, today only I will upload
Uh,
only.
okay, today itself, that means I'll go through once, then I will have more clarity once again listening.
Yeah, yeah. Okay.
So,
Can
thank
we
you, sir.
find? Yeah. Okay. Thank you. Okay. Thank you. We'll see you then next week. That
Okay,
the same timing.
okay sir. Okay,
Uh, okay. Thank you.
thank you.